In this video, section 0.3, we're going to be looking at tree diagrams, which a lot of times are used for conditional probability. The learning targets here are going to be to interpret a tree diagram to determine probability and to create a tree diagram given data. So this is an example of a tree diagram. It's a diagram to determine probabilities and list possible outcomes. All right. In example one, we're just going to be interpreting a tree diagram. So this is talking about baseball and comparing right-handed batters to left-handed batters. And given these batters, did they have to bat against a right-handed pitcher or a left-handed pitcher? When we look at this, just to kind of break it down, you have that, like for example, right-handed batters. For this league, there were 1,193 right-handed people that were right-handed and batted, and of those, 500 bats were against a right-handed pitcher, and 693 were against a left-handed pitcher. Of the left-handed batters, there were 255 that had a bat against a right-handed pitcher versus a left-handed pitcher. So if I was to call, like, let's say this was my right-handed batter, when you branch it out, this would be like having a right-handed pitcher given they were a right-handed batter. This would be a left-handed pitcher given they were a right-handed batter, and so forth. So this is just another way that we can look at conditional probability. And I'll kind of fill in the rest of this here. This isn't necessary to fill in, but it might kind of help kind of see why we would be using this. Okay, so the question then is, how many times did a batter come to the plate during this time period? So really there were only two types of batters here, 1,193 right-handed or left-handed. So we're going to just go ahead and add those two values together, and this is really just saying what's the sample size. So how many people ended up batting, and if we were to go ahead and add that up, it actually, these two numbers would add up to 1,610. The question then says, if you're a left-handed batter, so that adds a condition, what is the probability that you will face a right-handed pitcher? Well, if you're a left-handed batter, there's only 417 possible people that would be, so that's going to be the bottom. And of those 417, there were 255 that faced a right-handed pitcher. So if we go ahead and divide that out, that would be 0.612. For part C, it says if you're a right-handed batter, what is the probability you will face a left-handed pitcher? So again, it gives a condition. So for a right-handed batter, that would be 1,193. And of those, how many were also facing a left-handed pitcher? That was 693. And if we divide that out, that'll be 0.581. All right, and then finally, what is the probability that a left-handed batter would be at the plate for any given plate appearance, right? So this is not giving a condition like if this. It's actually taking it out of the total. So our total sample, so of the 610 batters, how many are left-handed? And that would be 417. And when we divide that, we would get a 0.259, or roughly a 25% chance that a left-handed batter would be up to bat. Creating a tree diagram can sometimes be a little challenging if you're not sure which, how to break up the data or sort the data out. So with it, it's sometimes helpful to work with a two-way frequency table. If you need to make a tree diagram, it makes it a little easier to go from there. So it says data was collected as customers ordered from a taco truck. Complete the diagram using the following information. So I'm going to use the two-way frequency table and then use that to help with making my tree diagram. So for my two-way frequency table, it says 500 people were observed ordering food. So that's my sample size. I'm going to put that in the bottom corner. And so 325 customers ordered an item that contained chicken. All right, so I know I'm going to be comparing something with chicken. Maybe I call that C. And then it says, so 325 customers had something that contained chicken. I'm going to write that total at the bottom. It then says 60% of people ordered a burrito. So there's 500 people. And we're going to say 60% ordered a burrito. And then I'm going to read the next line just to kind of see what I'm comparing here. It says, of the people who ordered a taco, 19% had no chicken. Okay, so what that I basically see here are some identifiers. So I see something with chicken, a burrito, a taco, no chicken. So that's going to help break up those categories. So we have no chicken. Let me call that N. And then we had burrito. And then maybe a taco. Okay, so those are my categories that we're comparing here. A burrito, a taco, a chicken, or if they had chicken or no chicken in their burrito or taco. So going back to then, we kind of did these bullets right here already. We then have 60% of people ordered a burrito. So of all the people, so of 500 people, 60% ordered a burrito. So I'm going to take that 500 and multiply it by 60%. But again, I have to write it as a decimal. So 60% of 500 is going to be 300 people. So that means that 60% ordered a burrito. So the number of people who ordered a burrito was 300. Okay, and so if there's 500 people and 300 ordered a burrito, 200 ordered a taco. Okay, we then have that of the people who ordered a taco, 19% ordered no chicken. So there are 200 people who ordered a taco. So of the 200 people that ordered a taco, 19% got no chicken. So I'm going to do the same thing, but this time I'm going to do it out of the 200 because that's what they gave us as like a condition. So 200 times 0.19. And that's going to end up giving us 38. All right, and now we actually have enough information if we want to fill out the rest of our table. So we know across what it's going to add up. We can do some addition and subtraction here. So if I put these together and gets 500, this would be 175. And then I can kind of fill in this rest by doing addition and subtraction. Okay, and then now I could use this information if I needed to fill in my tree diagram. So I know that these are like my little branches here, and then we can break it up for no chicken, no chicken, burrito, taco. It doesn't really matter. It really kind of matters how we want to make our condition here. So I might make it, since this had a condition here, I might say burrito and taco. So the number of people who got a burrito was 300. Number of people that got a taco was 200, and then I'd break it up from there. So I'm going to say chicken was 163, no chicken was 137, And then for taco, chicken was 162, and no chicken was 38. If you have any questions, please feel free to sign up for T-Bolt time, get help from the center,